Hello everybody and welcome to episode 48. We're really cracking on now. We're going to implement saving in this episode, okay? Just saving, and then the next episode we'll come to loading the other side of it, alright? So a lot of this episode is going to be based largely on the sort of saving and loading tutorials I've already done. Like I've done independent videos on saving and loading. I'm going to use more or less those exact methods to do our saving here because it's a fairly universal approach. What is going to be interesting about it is just that we're going to structure our data a little bit interestingly, because one thing a lot of people don't seem to necessarily always get with those tutorials is I show you how to save data in a combination of arrays and structs in my most recent one, or lists and maps, which is actually what we're going to do here. People are always, oh, but how do I save this kind of data and that kind of data, or my game, time of game, and so on. And the idea of those tutorials was not to show you a specific method for saving every type of game, but it was to show you the system, which is that you can save any kind of data if you save it as a combination of arrays, which is sort of a list of variables, and maps, which is like the other type of maps, or structs, the other type of data, which is where you get each variable has a name, like a readable name, but aren't necessarily in a fixed order. Okay, I'll probably put a diagram on screen to kind of show the difference between those two there. So we are actually going to use a map in this game, pretty much because I don't think we worry too much about very specific placements of things like that. Like in my saving and loading tutorials, we've done things where we save a whole bunch of instances exactly, so we almost get like a frozen save state of the game. Don't really worry too much about that in this. We just kind of want to save our overall progress. We care about what room we're in. We care about our inventory, our money, our health, all that kind of stuff, right? We just care about a quest status, with this character, that kind of thing. So we can actually store all that information in just a single DS map, all right? We're just going to do it in the simplest way possible. We're going to have one map. And we've used DS maps before as well, so I think it'll be easier for us to come along and use that. We used that for our quest status, probably in dialogue response. Oh yeah. So it was a simple one, admittedly, because I think we only did a single entry in this array, which is just the hat quest, right? But it was there set up so that in theory you could add more quests and so on, and put them all in this. But we're going to use the same system, okay? DS map, so everything will have, it's essentially like an array, but instead of using numbers to denote and a fixed order to denote where each variable is, we're using names. One thing I'm going to do is we're going to come to OGame, our big manager object, and in the create event, just right at the top here, make a little space, separate it out from everything else because it will kind of get moved eventually. But for the sake of this episode, we need to put this in for later. I'm going to type global.game save slot to equal 0, okay? Because that's when we come to the title screen, I'm going to show you how to make multiple save slots, okay? So we don't just have one save file that you're always loading and continuing from. You can have a handful, all right? So it's just a classic sort of Zelda thing, right? Just have a few save slots, and it's very easy to do, so I figured we'd tack that onto the tutorial as well. So we're going to do save slots, but for now we just want to assign the save slot to B0, and we're just going to act as if that's our only save slot for the time being, but we're going to kind of build the functionality in so we don't have to come back and modify our save script later. It's just sort of there for us, okay? All right, now we can get started. Let's open up scripts. We're going to make a new script. And we're going to call it save game, which will handily name this function for us. I'm going to bring this bracket down to the next level because I don't like it on that level. Give ourselves some space in here, and let's make this font nice and big because this is where we're going to be spending pretty much all our time today. Okay, the first thing we want to do is actually create the base map that we're going to save. So I'll comment that, create save map, and then I'm going to write var underscore map equals ds map create. It's only a var because we're only going to use it for this function, and then we're going to nuke it at the end, so we're not hanging on to it in memory. Once we've actually saved it to a file, we don't need it in our memory anymore, okay? So what are we going to do with this ds map? We're going to put all the relevant information that we want to save into it, and we can do that. You might remember from quest status, we just sort of wrote global.quest status and then open square bracket question mark, and then the name of the thing equals something, all right? And that's what we're going to do with this, okay? It's just going to be underscore map, open square bracket, this, equals whatever, and we're just going to put all of those relevant things in, okay? So just to start that off, underscore map, open square bracket, question mark, room. Wow, this is going to be a thorough test of my new keyboard today with the quotation marks and the @ key being the other way around. But at room is going to equal room, okay? So the word room we're going to use to be the address in this map of where we're storing the number that'll be whatever room we're currently in, okay? And then the same for player health. It's going to equal global.player health. All right, you get the idea. And we're going to do this with everything that I feel like we're going to want to save. Okay, and now rather than you sitting watch me typing out all of the others, I'm just going to copy and paste in the rest and we'll just go over it, okay? So I'm just going to paste in a whole bunch of these. Obviously you'll have to type it, so have fun. But these are all the things I'm going to save. I'm just going to go over them because it's important that we do get them all in. Otherwise, you know, you'll be loading in and be like, oh, why hasn't this been saved? And so on later on. But these are all the things I'm going to save. I'm going to save what room we're in, the player's health, the player's money, what items the player has unlocked so far. That's quite important. How much ammo each of them has. And you'll remember that these aren't just simple variables either. These are actually arrays. So we're putting whole arrays into this DS map as well. So the whole arrays are going into these maps for item unlocked, ammo, and so on. Player equipped, what item we currently have equipped is going to go in. Even though that's not super important, but it's useful to just sort of retain that. Whether or not the player actually has any items at all, that's just an important flag that we need to store. And target X and target Y will give us sort of where the player last spawned into a room, so we can just put them back there. And obviously if it's the start of the game and they're -1, the player ignores that, as you remember. Okay, so that's all of the basic stuff that we need to put in. The other thing that we need to put in is global quest status. Okay, you remember that one? But we can't simply do the same thing. We can't just write map equals global dot player, or what is it, global quest status. You might think we can just do that. But this won't quite work because this is the thing with variables, and I'm about to open your mind a little bit to the nature of how some variables and stuff in GameMaker works. So you might think of a variable as storing a piece of information inside of it, and it literally being whatever you put inside of it. So, and most of the time that's true. When we do like potato equals 5, you know, and we look at what's in potato later, we're going to get back 5. But when we look for a particular DS map, so if potato were to equal global.quest status, you might think it would return some like big chunk of data that has all of those things, like returning an array does. You can literally put an array into potato, for example. You know, you can put like 2, 3, 4, and then when you look later at what's in potato, you're going to get back 2, 3, 4. But when you look at a DS map or a more complex piece of data, you're not always getting that exact data back. You're actually getting a pointer to a specific point in memory where that data is currently held. Okay, so in this case, global quest status wouldn't actually return back the data which contains like the hat quest, I think it is, and the fact that the hat quest equals 1 or equals 0 or equals 2 or whatever it equals, right? You would actually just get back something like 4. Or whatever pointer has been assigned for this that tells it where to go. That's because that's how like all of our DS map functions work. If we like do this DS map and we do like global.quest status there as the ID for it, that's because that actually contains the ID, the pointer, the reference to the DS map, not the DS map itself, not the actual content of it. It's just the ID of it. Okay, similar to just instance names, you know, so like instance IDs. When we provide an instance ID to something, we're not actually providing all of the data with that, you know, like the name, the X, the Y, the image speed, sprite speed, and so on. We're providing the ID, and using that ID, we can access all that other data. But, you know, if we were to just save the instance ID of something, we're not saving anything about that instance other than its original ID, which would be no helpful to us. So this line doesn't help us because it's just saving the reference to the point of data where quest status is. So how do we actually save the map itself? Well, what we're going to do is we're going to copy what's currently in the map into a new map first of all. I'll go over why we're doing that in a second, but I'm going to write quest map, var quest map equals ds map creates. Okay, and then I'm going to write ds map underscore copy, useful function. How this works is we provide an ID and a source. So the ID is where we're copying this to, and the source is where we're copying it from. Okay, I kind of wish it was worded that way, actually. I don't like an ID. You get it by the time you get to source, but I kind of wish it was just phrased like to and from, like down here rather than ID and source, but yeah, it is what it is. So to is quest map, and from is global.quest status. Okay, so this one works because it's using the IDs of them to get all the data from this and put that into there. Then what we're going to do is we're going to use a special function called ds underscore map underscore add underscore map. It's a weird one. But what this does is it marks a particular entry of the a particular value of a particular map, in this case our save map, as containing the data of another DS map. So I'm gonna the key is just going to be quest status, so that's like this up here, like where it actually lives in the DS map, and the value is going to be quest map, so that map we've just copied quest status to. Okay, so that's actually going to put the data from that map, not the ID of the map, but the actual data itself is going to now go into the quest status location. Okay, that's what allows us to then actually be able to like save this map out and save the data rather than just save the ID of quest status. Okay, the reason we've made a copy of it is because when we structure things like this, we are actually able to do something quite handy, where when we delete this original map afterwards, because we don't want it anymore, it actually nukes all of the data within it, including any like maps and stuff and lists and things like that you've nested inside of the DS map. They all get cleaned up, which is great in terms of like not having to like you go through and do DS map destroy on a whole bunch of other things when you mark them in that way. It lets you nest structures within structures and be able to just delete the top one, and it just gets rid of everything, which is very, very helpful, but can be a problem here when if we were to just add all of this data as a map to the root one, and then we delete the root one, it would actually get rid of the quest status as well. So every time we saved the game, it would then erase our current quest status, which would not be good. So what we do to fix that is we copy that to a separate one first. So this data stays in the game, and instead the data that was in here gets marked as a map within the map here. And then when we destroy map, quest map also gets cleaned up, but this stays with us in the game because we still want this, presumably, if we're still playing the game. So that's why we do that. Hope that made sense. I know it's a little bit complicated. Get your head around. Maybe watch it a few times. I'll watch my other saving loading tutorials. We go over this, and maybe some different words might be helpful. But anyway, I hope that's making sense. Once we've done all that, we've got all the data that we actually want to save. I'm now just going to shrink this down a little bit. There we go. I'm going to save it to a string. Save all of this to a string. Now, first of all, we need to turn it into a string, and we can do that by doing var underscore string equals JSON underscore encode underscore map. All right. What that does is it's going to turn this DS map into a string in the JSON format. Okay, I go over this in the saving and loading tutorials, but JSON is basically a data format. Okay, and it stores things in maps and lists, or in its case, like objects and arrays. I think it's called in JSON. But they're the same thing. Again, it's those two types of data. It's lists, things that are numbered lists, and unordered named entries, right? And the way JSON structures it is that every list in it or every array in it will be like in square brackets. So you get things like that would be like an array, and then you get objects which will look like value 1, 25, value 5, 52, thing 32, and they look a bit like that, okay? And then they nest within each other, so you can have like an array that's like 2, 4, and then like an object that's potato 3, banana 4, and then even like an array within that, so you could have like the array 24, 52, close that array, close that object, close the original array. So you can nest arrays within objects and objects within arrays and so on, okay? And what we're going to do, and since that's so comparable to what this data is, DS maps and DS lists, and also structs and arrays and my other thing, what we can do is very easily directly convert this into a string that is JSON valid data. Okay, so it's going to turn it into something that looks like room 2 or whatever it is, player health 4.0, whatever it happens to be, and so on, right? And it's going to end up looking like that as a piece of data, as just one big string. And then since we have it as just a big string, we can just very easily save that to a file. Now, we could do that using file text functions, file text open write and so on, to create a text file, which works very well on PC. But I figure since you've come all this way, you've come all the way to episode 48, we're going to show you how to do something a little bit more fancy that is more cross-platform compatible. We're not going to go too deep on it, but I am going to show you how it works. So we're going to make a new function, and here we're going to call it function save string to file. I kind of stole the setup of this from Juju, and it's in my tutorial, my saving and loading tutorial specifically as well, but we're just going to go over it a little bit here. And what this does is we're going to, and the arguments are going to be file name and string. All right, so I'm going to provide a file name and the string that we're going to save, okay, which is obviously just going to be like savegame.sav and then this string, right? But rather than just save it to a text file, we're going to save it as we're going to write the data to a buffer and use buffer_save to save a generic file that just sort of contains the raw data. And by doing that, it just makes it a little bit more cross-platform compatible than saving like a text file that's a more PC specific file type, right? So I'm just actually going to copy in this little chunk, and I'll just go over it real quick. So it's a little bit complicated, and I'm not going to go into, because like the rabbit hole is a bit deep here for like going into what all this stuff means exactly. But the way to understand a buffer is that a buffer is just like a raw piece of memory, in a sense at least, that we can just write data to and hang on to and do various things with. The main uses for it is, well, the clue is in the name, to use it as a buffer. So usually it's when you're converting one type of data into another or something like that, or you need to inspect it at a very close level or modify it very manually. It's a little bit what we call in computing lower level than a lot of GML stuff is. It's not exceptionally low level, but it's lower level than what a lot of GML stuff is, which is an anti-intuitive word in computing, because what that means is usually that it's more complicated. It doesn't mean more complicated. What it means is it's closer to the hardware a little bit, whereas something that's considered high level in computing, which is GML in general. GML is a very, very high level language. It means it is more abstracted, more like further away from the actual physical hardware and the moving of ones and zeros around that makes your computer work, okay? The further away that is, and the more like you're giving instructions that convert to other instructions that are other instructions that eventually find their way to, you know, the ones and zeros moving around. The further away you are from that, the more the higher level it's considered to be. It's like a depth sort of thing. So the lower level you are, the deeper and the more manual the work that you're doing is, okay? So that's what I mean when I say low level versus high level. Just in case I haven't covered that before, because it's kind of a useful thing to understand when you're learning anything about computers and computing in general. Okay, so buffers are just a little bit lower level. So like when we create a piece of memory, we actually have to define the size of that memory, like in bytes. Which is just going to be however long the string is that we pass through to it, and the type of buffer. There's several different types of buffer depending on, you know, whether it's a fixed size, whether it can grow over time, and that kind of thing. And its alignment, which I don't even fully understand myself. I'm not even going to get into. Okay, if you want to learn more about stuff, just middle-click buffer, create, go to the buffer section of the manual. There's a good explanation there, but it does go very beyond the scope of this tutorial. The point to understand is that it's a bit low level and a bit more manual, and because of that, it allows us to create much more generic type of file that will work on other platforms, so your consoles, mobile, and so on, more consistently and reliably than like just saving a text file, which, you know, imagine telling your Xbox to save a text file, you know, like hopefully that gets across why like this is more cross-platform compatible. So that's why we're doing that. But it's very simple. We just create the buffer, we write the information to the buffer, and we save it to whatever the file name is, and then we get rid of it afterwards. Okay, so we've just created a little function that just allows us to pass a string and a file name and save it. All right. Again, just read the manual if you want to learn more about the exact way this is set up, but hopefully it's fairly self-explanatory. So now that we've got that function, once we have the string, we can go ahead and do save string to file, and the file name is going to be save plus string open bracket global dot game save slot. So this is where that comes in. Okay, so we can just, like, obviously game save slot is going to be 0 for now, so we're going to turn 0 into a string version of 0. So the eventual name is going to be save 0 plus whatever file extension you want to use, which is kind of irrelevant. I'm just going to go .sav, sav for save game or whatever makes sense, right? And then after you provided that, we just need to provide the string, which is the big chunk of JSON that we actually want to save. Okay, close bracket, semicolon. Why is that blue? Oh, it's not. There we go. It caught up. Then what I want to do afterwards is actually do show debug message string. That just means that it's going to pop up in this window down here when we're running the game, so we can see the data that we've just saved, and it's easy for us to just check that it's working and get some sort of feedback that it has happened. You know, once we've done that, the last thing we want to do is nuke the data. Okay, I'm going to do ds map destroy underscore map, and then also as well, once we're just properly done, I'll do another show debug message that just says game saved as well, just for a little bit more feedback on top. And as I said, when we destroy this map, it'll also destroy the map that we've put in it. Okay, so we don't have to destroy quest map as well, even though we've just created a new map there. It'll clean itself up automatically because we used this function. Okay, it kind of marks it in a special way so that when it gets destroyed by this, it'll destroy in a cascading way all the other things that are in it. All right, that's everything. So that's all of our save game functionality. We just need to actually call it now. So if we go to oplayer, I'm going to add the room start event. So just any room we go to where the player is, I'm just going to do save game. It's a very simple way for us to do auto saves at the start of each room, right? Then I'm going to run the game. Apparently it was running already. I didn't see it anywhere, but whatever. So we're in the game. It's actually already done it once, but we'll just go to a new room to highlight it because it'll come up in this output window down here. So just keep your eye on the bottom left of the screen for a second. Pop, and you can see that pop up there, and we'll zoom right in on it now. Kind of goes off the screen a little bit, but you can see the exact string in that same format that I said it would be in, right? So it opens with a curly bracket, player health 3, rooms ended up down here. As you can see, the order just doesn't matter at all. It saves it in a very arbitrary order. Is that, maybe it's alphabetical? No, it isn't, because player something else comes after there. No idea. Either way, you can't rely on the order being it because it's unordered, right? It's not a list or an array. So let's see, player health 3, player item unlocked, and then that contains an array inside there, and that's what an array looks like in JSON. And player ammo contains the array, player has items, player blah, 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 blah. And one thing you'll notice as well, if I would just scroll along to the end here, is also there's the DS, the map within the map that we've saved as well. So at the position quest status, we've got another map. And that's containing the hack quest and whatever the status is of the hack quest at that point in time. Okay, that's all there is to it. So I mean, when we just move between rooms now, we'll see it pop up again, like just doing game saved and sending that data. And if you pop to the appropriate folder, we can actually see the file there as well. So I'll just show you that very quickly before we wrap up. Okay, so if you go to your app data folder, which will be hidden by default, I think, so you might have to mark it to do Windows things to be able to see it. But then go to app data local and then the name of your project, which in this case just happens to be ARPG episode 47B. Don't worry about it, my naming gets weird. And you can see we've got save0.sav. I'm sure I've done this kind of thing before with these tutorials, so like it's already assigned to open with Notepad. It won't be by default. You'll probably have to right click and go to open with or something like that. But if you open it with Notepad, you can see that data is there. Okay, exactly the same as what got shown in the output window. In the next episode, we'll look at how to actually load this data back in. Okay. If you found this video helpful or you enjoy the work that I do, you should know it's only possible and only exists thanks to the help of my Patreon supporters. If you become one of them today, you can get access to my source code, videos before they even release, and have a vote on the topics that I choose to cover. Doing so will help me make more, better quality videos for the future that are free for everybody to watch. So thank you to all my Patreon supporters, and of course thank you for watching. I'll catch you all next time.